Chalo. Okay. So we are starting with work energy theorem, right? Work energy theorem, right? What is it? You know that work is equal to work is equal to force force into displacement. Displacement, right? Ab so W is equal to F into S, right? I told you this F belongs to M into A, right? into मैंने आपको बताया था थर्ड इक्वेशन ऑफ मोशन v स्क्वायर इज इक्वल टू u स्क्वायर प्लस 2s 2s right 2s so when just before just before start falling start falling falling u is equal to 0. What is u? That is initial velocity. Initial. You people are writing now? Initial velocity u is 0. So when we put this value here, so it becomes v square. No, no need of this. No need of this. Right. So we can write it is not required here. It is not required here. Right. So v minus u v square minus u square is equal to 2as. So you can write v square minus u square upon 2a is equal to s, right? So when we substitute this value in here, so we can write v square minus u square upon 2a. This a and a is cancelled out, so you get w is equal to m bracket v square minus u square upon 2. So we can write half m v square minus u square. So we can write half mv square minus half mu square. So it means work done is work done work done work work is equal to difference in difference difference in kinetic energy. Kinetic energies. Take So this is work energy theory. I hope you understand. Okay. Should I rub this down? Pratham, you have done? So now we will talk about relation between linear momentum and kinetic energy. Right? Relation 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 between linear momentum linear momentum momentum and kinetic energy. Kinetic energy. Right? So can you tell me what is linear momentum? Linear momentum P is equal to product of product of mass and velocity. Velocity. So we can write T is equal to m into v. So we can write P upon m is equal to v. Right? Now now what is kinetic energy? Kinetic energy kinetic energy kinetic energy we use with the symbol k here. So k is equal to half m v square. So when you substitute the value of you know v here, so it becomes half m p upon m whole square. In place of v, we write this, right? So we can write k is equal to half m into p square upon m square. So one m is cancelled out. So you get k is equal to p square upon 2m. Right? Yeah, you can write p square is equal to 2am. Now taking square root both sides, so we get p is equal to square root 2km. Right? Or 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 kinetic energy is equal to p square upon 2m. Getting? This is the relation between potential energy, linear momentum, and kinetic energy. I hope you understand. Okay. Anything else is left? I told you. Hmm. Degraded energy. Where you read this? क्या क्या पढ़ो जरा पढ़ो नोट पढ़ो. हाँ 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 पढ़ो. हाँ. ओके ओके. बस समझ गया. ओके ओके फाइन फाइन. Leave it. Actually, what happens? Nothing is 100% in this world, right? So suppose suppose this is the solar energy. Solar energy converts into, yeah, convert stored stored in solar battery, yeah, solar cell, in the form of chemical energy. And this chemical energy convert into electrical energy. electrical energy Electrical energy. So what happens? transfer of energy transfer of energy transfer of energy is not 100%. Not 100%. some amount of energy some amount of energy gone waste, or utilized by system to overcome resistance resistance of system, right? मतलब everything resists the change, huh? So that we have to apply an external force. So some amount of energy always or utilized by system to overcome resistance. This amount of energy is known as this energy is known as degraded degraded energy. Degraded energy. But in initial in lower classes, we assume that there is no loss of energy. We assume, it is our assumption that there is no loss of energy. No loss of energy. This is assumption we do. We assume no loss of energy. during change in form. But exactly it does not happen. But exactly, but exactly does not happen, right? नहीं, आपसे डिग्रेडेड एनर्जी पूछ सकते हैं तो आप ये लिखोगे कि जो एनर्जी गॉन वेस्ट हो जाती है फ्रॉम फ्रॉम ट्रांसफरिंग फ्रॉम वन फॉर्म टू अनदर फॉर्म, एनर्जी विच गेट मतलब विच गेट व्हाट कंज्यूम या गॉन वेस्ट अमाउंट, मतलब सम अमाउंट करे यार, सम अमाउंट ऑफ एनर्जी, some amount of energy gone waste or utilized by system to overcome resistance of system. This energy is known as degraded energy. I hope you understand. Okay. Now, one more thing we have. Should I rub this? I should. Okay. I told you mechanical energy, mechanical energy changes in two forms. One is due to position, due to position called potential energy. Due to position it is called potential energy, potential energy, right? And we have two type of potential energy: gravitational, that is equal to mgh, right? And we have gravitational potential energy, right? And second is elastic potential energy, elastic potential energy, right? Then we have kinetic energy due to motion, due to motion, due to motion, due to motion, kinetic energy, kinetic energy, right? एंड काइनेटिक एनर्जी में फर्स्ट आता है ट्रांसलेशनल 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 काइनेटिक एनर्जी, ट्रांसलेशनल काइनेटिक एनर्जी, राइट? सो when when each point of an object moves equal distance in equal time interval, sorry, in मतलब in equal time in same direction, in same direction, same direction, then same direction, then Translational kinetic, then translatory motion. Translatory motion, right? Translatory motion and energy used called translational translational kinetic energy, right? Another we have rotational energy, rotational kinetic energy, rotational kinetic energy. When an object when an object moves about a fixed axis, then rotational motion. Rotational motion, right? And energy energy used known as rotational kinetic energy, right? One more we have that is known as vibrational kinetic energy. That is called vibrational 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 kinetic energy, right? So what is vibration? To and fro, to and fro, to and fro movement about mean position, right? Mean position. And energy used in it known as vibrational kinetic energy. Yeah, energy energy used in it known as vibrational kinetic energy. I hope you understand. So this is kinetic potential energy. This is different type of kinetic energies, right? Then you have different form of energy, right? Like solar energy, like energy, tidal energy, geothermal energy. So many type of energies are there, right? Tidal energy, nuclear energy, energy getting nuclear energy is an energy getting from the nucleus of an atom. That is known as nuclear energy. So there are so many types of energies are there, right? And energy, as I told you yesterday, by law of conservation of energy, energy can energy changes from one form to another form, right? So this is what we have, and in remaining chapter, this is written. So you go through with that. If you are not able to understand anything, then I'll explain you. But these things were important, huh? यार, you just read it like a storybook. You just read it like an energy, मतलब a storybook. Then nothing is complicated, right? Wind energy is you are getting energy by blowing of air. Geothermal energy you are getting that by heat coming out beneath the earth's surface. Nuclear energy, I told you that energy getting from nucleus of an atom. Hydro energy is hydro energy we are getting kinetic energy of running water. This is hydro energy, right? Then you have different type of energies. You can say magnetic field. So magnetic energy, right? Then इलेक्ट्रोस्टैटिक एनर्जी, चार्जेस के बीच में जो एनर्जी होती है उसको बोलते हैं इलेक्ट्रोस्टैटिक एनर्जी. So they are just transferred in one form to another form. By law of conservation of energy, they just change it from one form to another form. You just go through with that. If any point you are not able to understand, you can ask me. Right. So this was your second section, which I completed. Right. Now we are coming. Even that I have done third also, because I told you at different point energy remains same. Right. Uh-huh. Hmm. Hmm. There is one thing left. There is one thing left. Which, that is when we are talking about pendulum. Pendulum may kinetic energy always remains same. When during an oscillation. So this is the pendulum, if this is the pendulum, right, and this is the ground state, right, this is the mean position, right, and when you bring this, suppose this bob comes here, right, so when it comes here, so it's, it comes like this, so this is the height h, right, when and this is the amplitude we have. Amplitude is maximum displacement from mean position. This we call amplitude. Amplitude. What is it? Max, maximum displacement. Maximum displacement. Displacement from mean position. From mean position on one side. On one side. Right. This is known as amplitude. And this is height h. Then this this goes here, right? When it reaches here at maximum height, potential energy is maximum. Potential energy is maximum, and velocity is zero. So kinetic energy is zero. So total energy is equal to mgh, right? Mgh. Now, when it comes back to this position, so here, uh, uh, H is equal to 0, so potential energy is 0, right? So potential energy is 0 and velocity is maximum. Velocity is maximum. So kinetic energy is equal to maximum at mean position. At mean position, right? Velocity is maximum at mean position. Again, when you come here, matlab it comes from, from here it comes to here. So this is the horizontal line, right? So again, in one oscillation, height remains same. This height remains same. So again, height is h, and at maximum height, height potential energy is maximum. Potential energy is maximum, and here will be total energy is mgh, right? And here also potential energy is maximum, right? At maximum height, potential energy is maximum, and velocity is 0, so kinetic energy is 0. Kinetic energy is 0, and when kinetic energy is 0, then kinetic energy is 0, so total energy is equal to potential energy plus kinetic energy is equal to mgh. So at every point, sum of potential energy and kinetic energy is same during the oscillation of pendulum, and then it is going here and it will come back to one oscillation, right? So during the completing one oscillation, at every point total energy remains same. At highest matlab at highest displacement, at the point of highest displacement, matlab maximum displacement, height is maximum, so potential energy is maximum, and velocity is 0, so kinetic energy is 0, so their sum is equal to mgh, right? At mean position, height is 0, so potential energy is 0, v is maximum, so kinetic energy is maximum, so at mean position total energy is mgh. And when, and again, on the other side, when it reaches here, then here at maximum height, potential energy is maximum, velocity is 0, so kinetic energy is 0, and total energy is equal to mgh, right? So during one oscillation, this is the during one oscillation, during one oscillation, during one oscillation, during one oscillation, total energy at every point, every point remains same, remains same, right? This is what we have about pendulum. I hope you understand better understand. Okay. Should I rub this? Should I? So, so now we come to numericals. Can you give me a cup of tea, please? Can you give me a cup of tea, please? Okay. So now we come to numericals, right? What are those? 1, 9. Adhika, send a copy to Pratham also. Maybe he is having a different set of questions. So, question number 23. Question number 23 is that a spring is kept compressed by a small trolley. You know, this is the wall, this is the wall, right? And there is a trolley. There is a trolley like this, right? This is the trolley, and it is kept compressed by a spring. This is right. This is kept compressed, compressed. So what happens? And mass of trolley is 0.5 kg. Mass is equal to 0.55 kg. Right. Now, when the trolley is released, when trolley is released, when trolley released, uh, trolley released, then then moving with a velocity of velocity of 2 meter per second. Very nice. So, what is asking? What is potential energy? So by law of conservation of momentum, right? By law of conservation by law of conservation of energy 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 kinetic energy kinetic energy is kinetic energy plus potential energy is equal to constant, right? At rest, at compressed condition, at compressed condition V is zero, therefore kinetic energy is zero. So total energy is equal to potential energy. And when moving, when moving with with maximum speed, moving with maximum speed, then Potential energy is zero and total energy is equal to kinetic energy. Right? This is equation 1. This is equation 2. On equating, on equating, potential energy is equal to kinetic energy. Therefore, half mv square. So 1 by 2, what is mass? 0. So, eh? Sure. 0.5 into velocity is 2. So 2 ka whole square. Right? So it becomes 1 by 2 into 0.5 into 4. 2 1 ja 2, 2 2 ja 4. It becomes, it is 0.5 into 2 is equal to 1 joule. Right? So potential energy is equal to 1 joule. Getting? This was your answer. You have written this. You wrote it down. Yeah. It means you are not understanding. You are just making a Xerox. Whatever statements I have written, though all those statements you have written, send me your copy. How can you write the same statement? This is the first time I did this question in this manner. So how you can done like that? How you equate that? Na? I made whole concept for that. So that concept is very important, man. Just saying that potential energy is equal to kinetic energy, that is a different thing. But I proved here, because kinetic energy plus potential energy is a constant, the law of conservation of energy says, and when compressed condition, then velocity is zero and kinetic energy is zero, then total energy is equal to potential energy. And when moving with maximum speed, then potential energy is zero and total energy is equal to kinetic energy. On equating this, then we get potential energy is equal to kinetic energy. चलो ठीक Anyway, anyway. Forget. Should I rub this? Now the question number 22. It's very good question. 99% chances it will come in your exam. From 99% chances that this question will come in your exam. Not exactly this, but similar to this. Figures may be different, that concept will be same. From your internal assessment exams to your pre-board and maybe in both. This is. So question is that, you know, there is a still target. This is a still target. There is a still target, and there is a bullet. I hope you have seen bullet is very small in comparison to target ना. देखा है? Like this. This is the bullet. Bullet is having a mass of 50 kg. Mass of, sorry, 50 gram, not in kg, gram, right? And its velocity is 500 meter per second. 500 meter per second, right? Per second. So when it reaches here, you fired it, it comes here. When it reaches here, when it reaches here, then it penetrates, goes inside the target, and then it will get stopped. Then it gets stopped. So it travels a distance of 10 centimeter. It means 10 upon 100 means 0.1 meter. Right? Displacement is 0.1 meter. Right? Here it is having maximum velocity, so u is equal to 500 meter per second. And when it reaches here, then velocity turns to be, here its velocity is v is equal to 0. Right? Velocity is, this is, we have bullet of mass. So velocity turns to be 0. So what is, calculate potential energy possessed by first, potential energy, kinetic energy, kinetic energy possessed by, possessed possessed by bullet, right? So that is equal to, kinetic energy is equal to half mv square. So that is 1 by 2, 50 upon 1000 into 500 meter, we can say joule it, right? So how much you get? These three zeros gone. Oh my god. You don't get worried, man. Why you are so worried? So kinetic energy mass is 50 gram. So 1000. Okay. Moving with a velocity of 50 meter per second. Right. So 1000 gram, 1000 gram is equal to 1 kg. Right. So, so 50 gram is equal to how much? That is 50 upon 1000, right? And bullet is moving moving with a velocity of 500 meter per second. Oh shit! 500 meter per second, na? So it should be in square. हाफ एम बी स्क्वायर होता है ना. So yes, it should be. It should be. I made a silly mistake, man. So this is 50. This is 1000. This is 500. Right. So अगर we go 50 बन जा 50, 52 जा 100. So we get kinetic energy. Kinetic energy is equal to kinetic energy is equal to 2000 2000 sorry, 4 zeros na. 2,50,000. 4 zeros. 2,50,000 divided by 40. 1 zero cancel. 4 6 are 24. 4 2 are 8. 4 5 are 20 and 0. So kinetic energy is equal to 6,250 joules. So one silly mistake I made. This is one v square I should do there. I forgot to do that. So because of that, there was some wrong answer was coming. So otherwise it is. So kinetic energy possessed by bullet is how much? 6,250 joules. Okay. Now the second part of question is what is that? Second part of question is what? Huh? Average retardation you have to find. Retardation you have to find, right? So V U is equal to 500 meter per second. V is equal to 0. S is equal to 0.1 meter. So V square is equal to U square minus no plus 2AS, right? So V is equal to 0, so it becomes 0 square. 500 means 2,50,000 plus 2 into 0.1 into S. When you bring this on the other side, it turns to be 0.2 S is equal to 2,50,000, right? So S is equal to it is asking for retarding force. We are getting this. Oh my God! Displacement we know that we have to find A. This is given us 0.1 meter. So we have to find A. So A negative of A is known as retardation. So negative of A is retardation. So 2,50,000 divided by 0.2. This is 0. It is 2 1 are 2, 2 2 are 4, 2 5 are 10. Oh my God, it's very high. 12 lakh. Uh, uh, 2 1 are 2, 2 2 are 4, 2 5 are 10. यहाँ तक गया 4 जीरो लगाने, एक लगा दिया, 3 और लगा दिया, ये हो गया. तो रिटार्डेशन इज 12,50,000 meter per second square, right? Now force is equal to retarding force. F is equal to m into A. So m is how much? 0.05 kilogram. 50 upon 1000. Right, right. Now acceleration is 12 lakh, 12 lakh, 50,000, 50,000. You have removed decimal from here. You have taken 100. These two zeros are gone. And when you multiply it by this 0, 5 5 are 25, you get 2, 5 2 are 2, 0, 5 5 no, one more 0 is there. So 5 5 5 5 25, we get 2, 5 2 10, 2 12, we get 1, 5 1 5 2, this 62,500 Newton. Retarding force is this. Retarding force. Get it? This type of question will definitely come in your exam, right? So we have done this. Doing? Do it, do it, do it. Do it a little bit fast. Oh, yeah, you would tell me that like this. Okay.